Hello folks. So today I'm kind of bringing a video to talk about an experience that I had that I'm sure some of you guys have had as well, while at the same time maybe showing something that I learned today. Long story short, I interviewed with a particular company today and they basically had me do a tech session for them in which I sat down with one of the engineers and we worked through a problem in Unreal. And in this particular case, I was kind of surprised with a shader test. Now, I feel comfortable working on shaders, but as a generalist tech artist that can be working on anything from Python tooling to DCCs, characters to physics, I'm usually not 100% in materials. So this was kind of an interesting situation where the test definitely made me feel a little bit like a fish out of water. The test was relatively simple, as the goal was basically to put together a pretty simple shader that allowed us to procedurally turn on random windows and buildings via some shader coding and some embedded data that the engineer had put into the scene that I could use in my shader to drive all of the logic. Now I have two disclaimers to say about this. The things that I'm about to show you might be incredibly simple if you are an experienced shader writer, but this is something that I had to figure out in the period of 2 hours. And sadly enough, the second part of the disclaimer is that I did not actually pass this test as I was not able to fully finish the shader. With that said, while I knew that I was probably gonna get rejected, sadly, for not being able to finish the entire test and deliver a finished shader, I did use this as an opportunity to try to grow my knowledge around shaders, and I took a few extra minutes after the interview to basically wrap up the functionality that was asked of me so that I could figure out all of the things that went into actually passing the test. So with that said, let's look at the shader. So the shader is this particular material instance that I have here. And as you can see, there is quite a few features that we've added into the shader. So the first one was we needed to be able to just simply turn lights on and off. So here, notice that I can basically turn off the lights of the buildings. And I also wanted to be able to add a light color so that I have some control over how hot or how cool the temperature inside of the building was actually going to be. So here, let me see if we can zoom in a little bit closer into one of these guys. Here we go. So here you can see that as we move the color of the light, we are able to actually change that. And as I said, we can turn off these lights on and off. Now, the tricky part of setting up this particular shader was really the idea of randomness, as this relied on some data that had been embedded in UV channels that we could basically use to create kind of like a grid tiling system. And then off of that, generate some thresholds that we could use to randomly turn stuff on and off. So the way in which I set this up, notice that here I have a percentage. So this percentage basically allows us to choose how many of the lights are going to be turned on. So this percentage basically allows us, it's kind of a weight, it's not a perfect percentage, but it does allow us to basically say, I want 0, I want 1, let's switch that color again. I want 1, and then choose something in between or scale it down to start basically randomly turning off windows. And the other thing that I added was this random sieve that basically allows us to kind of change the pattern in which these particular random values are generated. And here you can see that I've kind of changed that. And so if we look at our building, we can see that there is a pretty good amount of randomness in our materials and how our lights are getting turned on and off. So how did we put this shader together and what were the challenges? So as I said, this is the material instance. So this is pretty simple here. Two things that were pretty important that they added is that they gave me two different map types. They gave me a diffuse map that basically drives the diffuse. And then they gave me kind of like a really nice specularity map that actually allowed me to separate the windows from everything else. So here is the shader graph that I put together. So this is where the basic shader starts. As you can tell for this particular example, I chose to simplify things and just connect the diffuse and never mess with the diffuse. So all of sort of my implementation, just for the simplicity of the shader, happened into the emissive channel. So really it's going to be the emissive channel here that is doing most of the heavy lifting. With our first switch here being this on and off, and basically if this is on, then all of this logic back here is basically what's figuring out the randomness. But if we were just to pipe a 1 here and say everything is on and not sort of do the random logic, then we can see that our overall process is relatively simple. We're using that specularity map to step it up, and here we can preview this guy, and here you can see that basically we're through step, we're turning this into a black and white map, and then we are using this black and white map to basically multiply it against our light color, and then if the light is on, then we plug it into emissive. And that is a pretty simple implementation on how to just use emissive and a mask to start driving the emissive channel. So that's all pretty simple. That basically allows us to illuminate and turn our lights on and off. But the tricky part of the test, and the one that I was not able to finish up, was the idea of randomness. And that's because I don't spend a lot of time in shader world, and randomness, as I found out today, is something that is very computational intensive. Usually when we're doing like offline tools, we usually rely on pre-built random functions, but those don't work too well on shaders, so you have to figure out another way to create randomness. Before we get into that, let's talk about some of the data that the engineers made available to me. So basically they gave me a little formula here to figure out basically sort of column and row numbers that are a combination of the coordinates of the UVs along with some information about the number of rows and number of columns that a particular object has that was embedded into a secondary UV channel. So this is basically the algorithm that I was given, and through this algorithm what I was able to do is generate a two-dimensional vector that basically for each one of these tiles, these texture tiles, it lets me know, basically this is row 1, column 1. This is row 1, column 2. This is row 1, column 3. And basically you can work yourself out, but that's basically the data that they made available to me. So that means that we have for every sort of UV tile, we can actually come up with a row and column number that is unique for that tile. Having this little two-dimensional vector was basically what we needed to use to be able to generate random data. So what I've done is I looked up this sort of different ways in which people come up with randomness inside of shaders, and it seems like this particular approach of using a sine wave to basically generate noise and run your input values through a sine wave noise is a common way of generating random numbers that for the most part line up somewhere between 0 and 1. To understand this a little bit closer, we can basically see that a lot of the magic starts in this dot product right here, because basically we're able to grab those two coordinates, that column and row, and by doing a dot product, we're actually able to get like a single number that gives us this description of the similarities in direction of the two vectors. And so that's really cool because that means that we can combine things like row, columns, and any other information that could potentially land within an array and break it down all to like a single sort of unique float that's a combination of all of these different values. However, in order to do dot product, we need to grab our floor, which as I said is row and column for the particular type. And we need to basically compare it to another array. So I went ahead and I just made an array using my random seed, and then I can then do the dot product and I can basically get like a scalar out of that, right? The next thing that we do is that we're gonna run this through a sine curve to actually generate some of the noise. And then I'm going to multiply it again by the random seed, which basically gives me like a bigger amplitude of the noise. And then in order to make sure that my values are between 0 and 1, I'm just gonna use the decimal part of the numbers that they get generated through this function. And so what this does is that this basically allows me to say, use the row and column that I can extract from the UV information, run it through a sine wave, and then in the very end, generate a pseudo-random number that's somewhere between 0 and 1. Once that random number between 0 and 1 is generated, the next thing is to actually filter all of the columns or figure out if based on this number that was was generated based on row and column, if I should filter it out or not. So since this guy is a value between 0 and 1, I can basically use an if statement to say, hey, anything that is less than my percentage, turn it on. Anything that is more, just ignore it, right? And that's basically what this if statement is doing here. And this basically pipes into our if statement to feed the rest of our emissive. So we basically have sort of two on processes, and I did try to sort of structure this in a way that would use the least amount of switches so that we don't just have all these switches evaluating all over the place. That's another thing that when I first implemented this shader, I was just kind of thinking about features and I didn't necessarily like optimize the flow of the logic too much. But in this particular case, I tried to be a little bit more conservative and really think about how I could sort of use less switches and also make sure that like my switches or my if statements are also gatekeeping certain logic, right? Like if I don't need to evaluate all of this filter out because the overall lights are off, then we don't want to evaluate that part of the code. So anyways, this is the final material that I came up with. Just wanted to share it with you guys and really sort of just share that experience of being in a job interview where the criteria of what is required for the job isn't necessarily super strictly defined. So you might go in as a generalist with certain weaknesses and strengths, and you might still be very experienced, but the test that they might throw your way might not necessarily be the one that highlights your strengths the most, right? It's something that as a seasoned kind of tech artist, I'm sort of used to. Sometimes this kind of coding exercises or coding tests can be pretty brutal, especially if you're not a great test taker. With that said, I was pretty proud that I was able to, even if it was on my own and it was a little bit later, and unfortunately I missed my boat to actually get an offer on this particular job, I was pretty proud to just be able to sit down and pull a shader out of nowhere, as I think that these type of tests can also be a really good way to test your overall engineering skills, especially if you're a generalist like myself. I know that, for example, if I ever go into another interview and I'm asked to do a shader that has some sort of random component that I can't necessarily derive from a pre-made texture, such as this row and columns, then now I know an algorithm that I've picked up that I can use to create a similar effect. But anyways, guys, this is what I did today. As I said, just a couple of hours worth of work. Maybe this will help some of you guys pass a coding interview. If you guys are asked to create some on-demand pseudo-random generator algorithm that's friendly to pixel shaders, maybe this will give you some insight in how you can do it. If you've had a similar interviewing experience where you were in the middle of an interview and then you found yourself to be a bit of a fish out of water, please share that with me. I would love to hear your stories, and I'm sure that I'm not the first one that's gone through that. I'm sure maybe other people would like to hear those stories. Anyways, thanks for watching. See you later. Bye.